AP Cactus AB Unit 5 review, corrective to help you get ready for the retest. So let's try these out. I'll try and point out some of the kinds of mistakes I saw a lot on the test. These first ones, we're just trying to find the derivatives. I personally would rewrite this one as 5x to the negative 2, unless you really like the quotient rule. So f prime of x equals 6x plus 10x to the negative 3. Negative 2 times the negative 5 is positive 10. Now, I don't want any final answers with negative exponents, so we will rewrite this as 10 over x cubed. The 10 doesn't have a negative exponent, it stays in the numerator. All right. Now, this next one is a product rule. If you don't do the product rule, I'm taking off most of the points right away. So that means you need to do x cubed times root of cosine, which would be negative sine, and then plus cosine times root of 3 x cubed is 3x squared. You do these first and then those. It's up to you. Final answer should be written a little nicer. Negative x cubed sine x. So we make sure anything's in front of the trig. Plus 3x squared cosine x. That's the way we want to write it. This one, I'm just going to do quotient rule. So quotient rule is low. I put parentheses around it. D high minus high D low all over low squared. So I like to use a lot of parentheses on these. So now we just need to simplify it. So we got to distribute that. So we can get 8 minus 4 sine x plus 4x cosine x. And the bottom, I think we could just leave factored. The only reason, it might be helpful in reducing if we leave it factored. Can we reduce anything out of everything on the top? I guess we could take the 4 out. But that's it. So it doesn't really do anything. So like this, it could be multiplied out. It could just look like that. And there's some other, variations you could come up with. But that's quotient rule. Secant co-tan, we might consider, we could just do it the way it is. Say, okay, well, f prime, it's a product rule, right? So it's going to be secant times derivative cotangent, which is derivative tangent is secant squared. So cotangent is negative cosecant squared plus cotangent times derivative secant is secant tan. Now, I think we could probably try and write this simpler now. Secant is 1 over cosine. Cosecant is 1 over sine. I don't really know if that's that much better. We could try it. I think that would just be better to leave the way it was. Cotangent is 1 over tangent, right? And secant is 1 over cosine. And then you have tangent. And those guys cancel. So, we could say, okay, well, the answer is, I guess we could say 1 over cosine x sine squared x plus 1 over cosine x. I don't really think that's better. Or we could say negative secant x cosecant squared x, and then maybe for this next one, just say secant x. And that's fine. Now here's the interesting thing. If at the beginning we change everything sine and cosine, secant is 1 over cosine, cotangent is cosine over sine. Those cancel, you just get 1 over sine. which is cosecant. So it could just be cosecant. The derivative cosecant is negative cosecant cotan. Now, this is the same as this. We'd have to use some Pythagorean trig identities to change this to look like this or vice versa. But that kind of was an interesting, nicer way of doing it. Now, problem 5, I would multiply all of this out. I would think of this as x to the negative 1, and I would distribute it and get 2x to the 1 plus 3x to the negative 1. And then distribute all this. So I'm not doing calculus yet. I'm just simplifying this. So it's going to be 2x to the 0 plus 6x to the first plus 3x to the negative 2 plus 9x to the negative 1. That's going to be 1. Write it in standard form, highest power first, 6x plus 2 plus 3 over x. Oh, wait, I haven't even taken the derivative yet. Okay, I'll just, whatever. I mean, we could do 6x to the first plus 2 plus 3x to the negative 2, or 9x to the negative 1 plus 3x to the negative 2. So this is like standard form. So I've just rewritten it. I haven't taken the derivative yet. Now, if I take the derivative, it's going to be 6, derivative 2 is 0, minus 9x to the negative 2, minus 6x to the negative 3. Final answer should be written without negative exponents. So 6 minus 9 over x squared minus 6 over x cubed. So something like that. But that would, my advice is multiply it all out at the beginning for that problem. Okay, let's see. Next one, number 6, true, false. You know, you got to support your answers with me. It says that the third derivative is equal to the first derivative negative. Well, this looks like one of those patterns. This is the 0th derivative. First derivative is cosine. Second derivative is negative sine. Third derivative is negative cosine. Fourth derivative is positive sine x. And now we're back to the beginning. So it's groups of 4. But I mean, this one is, if they'd given us a bigger derivative, like the 20th derivative, then you really want to use the pattern. But I guess we could literally just say, okay, well, here's the third derivative. That equals negative cosine x. And then the first derivative is cosine x. And this is true. So support your answers. True, false. Okay, number 7, a second derivative. So the first derivative, y prime, derivative of cosecant, is negative cosecant cotan. And then the second derivative, we're going to have to do a product rule, right? Now there's a product rule. So it's going to be negative cosecant, and derivative cotangent is derivative tangent secant squared. Cotangent is negative cosecant squared plus cotangent x. Derivative cosecant is negative. There's already a negative. Negative cosecant cotan. So then we could clean it up. Positive cosecant cubed plus cosecant x cotangent squared. Sounds good. So you just got to be good at all your derivatives, okay? We're also going to use them to do things like find equations of tangent lines, or slopes of tangent lines, and things like that. So we want to find the equation of the tangent line to this. So one, we need a point. That's not calculus, so it's just plugging in the value. What's tangent of pi over 4? Well, that'd be the same thing as sine pi over 4 over cosine pi over 4, which is root 2 over 2, root 2 over 2, which is 1. So you have a point, pi over 4 comma 1. You need the slope. So y prime equals derivative tangent is secant squared. So then we're going to plug pi over 4 in. Now, secant squared is 1 over cosine squared. And cosine pi over 4 is root 2 over 2 squared, which is going to be 2 over 4 which is going to be 4 over 2. If you multiply by the reciprocal, it's going to be 2. So this is your slope. So your equation is going to be y minus 1 equals 2 times x minus pi over 4. I would just leave it like that. I would not change the slope in a step form because that takes more time and leads to more mistakes. Find the value of k. So this is tangent to this. Well, what do you know about tangent lines? Well, you have a curve and a tangent line, right? They share a point and they share a slope. So those are two things you need to use. So the point, they can have the same y values, just set their y values equal to each other. Right? So that's one relationship. Not enough. And then you want to do the derivatives. So the derivative of this one is 2x, and the derivative of this one is 8. So you set those equal to each other. And this gives you x, which is not what you're looking for, but you need it, because now you can plug that into this equation and find y. It's the system of equations. So we're going to plug x equals 4 in. And we're going to get k equals 22, which is wrong compared to my answer. So what did I do wrong? Oh, this minus somehow became a plus. That's weird. 6. You should get 10. You just gotta be careful. Even I'm making mistakes. I'm going too fast. Okay. Find all the points where that function has a horizontal tangent. The horizontal tangent, the slope is 0. So we got to find the slope. Y prime derivative of secant is secant tan. And we're going to say equals 0, which means that secant equals 0 and tangent equals 0. Now secant is 1 over cosine. Is that possible to ever equal 0? No, because that would be the same thing as cosine equals 1 over 0, which is undefined, and cosine is never undefined. Tangent is sine over cosine. So more specifically, sine equals 0, which happens at 0 plus pi k. And for us, that's going to be 0 pi, 2 pi, negative pi, negative 2 pi, based off the directions. Those are the, now these are the x coordinates. It does say points, so that kind of makes me think that we should find the y coordinates, go with it. Y of 0 would be 1 over cosine of 0, which is 1. So that would be 0, 1. Y of pi, 1 over cosine of pi, which is 1 over negative 1. So pi negative 1. I'm thinking some of these guys are going to repeat. 2 pi would be 1 over cosine of 2 pi, which is the same thing as 1 over cosine of 0. That's going to be 1 over 1. So 2 pi is going to be 1. And negative pi, over cosine of negative pi, that's also going to be negative 1. And negative 2 pi. 1 over cosine of negative 2 pi is 1 over 1. So negative 2 pi, comma 1. So maybe that's a better answer. That's x and y coordinates. If it just said x coordinates, we would just go with the x's. But 11, find A and B such that the tangent line to this curve at this point has this slope? Well, maybe we should find the equation. Well, let's see. This is the xy pair, right? And let's see. We know that if we plug these in to the original equation, 40 in for y, 4 in for x, so 40 equals 16a plus 4b. So we have one equation. And then the slope thing, well, the derivative of this is going to be 2ax plus b. And then that should equal 22 when x is 4, y is 40. So we can plug x is 4 in. And we get 8a plus b equals 22. Now, you have a system of equations to solve. You could use elimination because they're both linear. You could use substitution, solve for one in terms of the other, and plug that in, which is usually probably the most universally appropriate method. So we just got to be careful. Just keep going, keep solving. A equals 3, which means that b equals 22 minus 8 times a, which is 3. So it's 22 minus 24, and b equals negative 2. So there you go. A equals 3 equals negative 2. So next one's a piecewise function. Determine whether f is differentiable at x equals 1. If so, find the value of the derivative there. So differentiable does require continuity first. So you really should be checking if the y values are equal at 1. So we can plug 1 into both of them and show that they work. You gotta show it. So that's continuity. Now, differentiability means you gotta take the derivatives. The derivatives have to agree with each other. So 2x, and this is x to 1/2, so it's 1/2 x to negative 1/2. And so then if we plug 1 in, we get 2 on that side. And this is the same thing as 1 over the square root. We get 1/2 on this side. These are not equal. So it is not differentiable. Not differentiable. Okay, number 13, find a function y equals ax squared plus bx plus c, which is like standard quadratic equation, whose graph has an x-intercept of 1, y-intercept of negative 2, and a tangent line with a slope of negative 1 at the y-intercept. So this sounds kind of complicated. Maybe we should just start with one thing at a time. X-intercept of 1. So x-intercept of 1 means that the y value equals 0 at the same time. So we can plug 0 in for y, 1 in for x, and we get 0 equals a plus b plus c. So that's one function for a, b, and c. Okay, how about the y-intercept? So the y-intercept is negative 2, which means x equals 0 at the same point. So I'm going to plug negative 2 in for the y and 0 in for the x's. And we actually get c equals negative 2, so we got one of our values. The other one is that the tangent line with this has a tangent line with a slope of negative 1. So the tangent line would be the derivative 2ax plus b. And at the y-intercept, we know that x is 0, right? And then it should equal negative 1. So that actually gives us b equals negative 1. So now we can plug both of these into this equation to find a. 0 equals a, plus -1, plus -2, a equals 3. So then our function will be y equals 3x squared minus x minus 2. There you go. All right, some more derivatives. Chain rule is super popular. So that's where you have a function inside another function. So the chain rule says take the derivative of the outside first, leave the inside the same. Don't forget this 9. People just love to forget that. They just don't write anything. And you got to multiply by the derivative of what's inside. This is the chain rule. Now, you better put parentheses around this. This is multiple terms, 2x plus 2. You don't put these parentheses around it. It's really wrong. Now, for final answer, I don't need this multiplied out. That'd be insane. You cannot distribute these into here anyways with this there first. You beat multiplication before exponents, which violates PEMDAS. So we can just try and write it as nice as possible. Like, I don't know, the 10 for sure in the front, and then maybe the 2x plus 2 because there's a low power. And the x squared plus 2x to the 9th power. So that seems good. I mean, you could do some other stuff, but that seems fair enough. Okay, 15. Now, I had to rewrite this like that. People mess this up so much. That's what this is. The cosine is inside the power function. So chain rule says take the derivative of what's on the outside first, leave the inside the same. Right, so it's just power rule. Then multiply by the derivative of what's inside. Derivative cosine is negative sine. Leave the inside the same. Then times derivative of what's inside, 2, plus derivative of 5x is 5. So your final answer, probably just write -8. There's a negative, a 2, and a 4. Put that all out front. And then probably the sine 2x because it only has power 1. And then probably the cosine cubed 2x. So usually write it back in that kind of lazy form. Be careful. Parentheses. All right. So I would rewrite this as sine x to the 3rd power to the 1/2 power. Now you could combine these together and call it sine x to the 3/2. So then the derivative is power rule first, 3/2 in front, leave the inside the same, decrease it by 1, times derivative of what's inside. And final answer would be, I would put the cosine and then the square root sine x. So, that's how I do it. There's some other ways you can do it. It should come out the same in the end. This is all to the 1/2. I would think of this as cosine 2x all parentheses squared. So the derivative is going to be the outer derivative first, 1/2, 2 plus cosine 2x squared to the negative 1/2 times the derivative of what's inside. Now the derivative of 2 is 0, so you're going to get 2 cosine 2x to the 1st power, and then you got to multiply by the derivative of what's inside that, which is going to be negative sine, leave the inside the same. And then you have to multiply by the final inner layer, which just gives you 2. Wow, that's a lot. So let's clean it up. No negative exponents, so this all is going to end up in the bottom. We cancel one of these pairs of twos out. So on the top, we're still going to have -2 sine 2x cosine 2x all over square root of 2 plus cosine squared 2x. That was pretty good. No negative exponents. Rewrite it nice. Okay, this one I would rewrite as sine x over 1 plus x all squared. So squared is the most outer function. So f prime of x equals 2 times sine of x over 1 plus x to the first power, and then the derivative of what's inside here is going to be cosine, and the inside stays the same. And then the inside of this, the next step is going to be quotient rule, so it's going to be low d high minus high d low all over low squared. So then we could try and clean it up. This is going to be 1 plus x minus x. So those guys are going to cancel. So I think we're going to go with 2 sine x over 1 plus x cosine of x over 1 plus x over 1 plus x squared. Okay. Now, this one, I'd think of this as 3x and -1, because then you totally get rid of the quotient rule, and you don't even have to do a product rule, simple power rule. I would do that. Now, there is a big product that you got to do here. So f prime equals x cubed times derivative of sine is cosine, leave the inside the same, times the derivative of what's inside, plus sine of 3x and -1 times derivative of x cubed is 3x squared. So that's the derivative, so we just got to clean it up now. These x squareds are going to end up in the bottom, and they'll reduce that. So we're going to get a negative 3x cosine of 3 over x plus 3x squared sine of 3 over x. Looks good. Okay, next one. Ooh, this is I'm going to change this to squared like that, and we got a big product rule for sure. So f prime of x equals x cubed times 2 sine 5x to the first power times derivative of what's inside is going to be cosine of 5x, leave the inside same, times derivative of what's inside that. And that's just the beginning of the product rule, because then you still have your sine 5x squared times derivative of x cubed is 3x squared. So there it is. We try and clean it up. 10x cubed sine 5x cosine 5x plus 3x squared sine squared 5x. Something like that. Looks good. Okay. 21, find the equation of the tangent line to the graph. Okay, well, gotta find the point first, so we could do that. So that's going to be tangent of 4 pi, which is the same thing as sine of 4 pi over cosine of 4 pi. And sine of 4 pi is 0, cosine of 4 pi is 1, so it's going to be 0. So we got root pi comma 0. That's your point. Then we need derivative. Derivative tangent is secant squared. Leave the inside the same. Times derivative what's inside. 8x. So then we need to plug root pi into that. Now secant's 1 over cosine squared. Pi squared is going to be 4 pi. And cosine of 4 pi is 1, so that's all going to be 1, so it's going to be 8 root pi. That's your derivative. We got a point, so we're going to do 1 minus 0 equals 8 root pi x minus root pi. So, I mean, that's good. You could change the slope into a form if you want. 8 root pi x minus 8 pi. I mean, you just clean it kind of nice. All right. Implicit differentiation. So I think some people are having trouble with this. So we're taking derivative with respect to x, but the y's are already mixed in. And the y's are an equation of x that we just can't see. So it's like an inner function. It's like a chain rule opportunity. Now here's a product. So we got to do x squared times derivative of y is going to be dy dx plus y times derivative of x squared is 2x. I like to put parentheses around this just to keep it all straight. We have another product here. X times y squared is 2y the first dy dx plus y squared times derivative of x is 1 equals derivative of 6 is 0. So that's the derivative. So now we got to clean it up and solve for dy dx. So we got to get those on the same page. We also should distribute this. So I'm going to rewrite this a little nicer. X squared dy dx plus 2xy minus 2xy dy dx minus y squared. So we're going to get the dy dx terms together and factor it out. And then move all the other terms to the other side. Add y squared, subtract 2xy. And then solve for dy dx. So dy dx equals y squared minus 2xy over x squared minus 2xy. Now, if anyone in here is like, oh, I'm going to just cancel out the 2x plus y. No, you cannot do that. Your Algebra 1 teacher's crying. It's a bad thing. Okay, this one, I mean, we could just take the derivative as it is. Derivative of x is 1, and we do quotient low d high minus high d low. Now, the derivative at the bottom is going to have a product rule. Derivative 2 is 0. Negative x times derivative of y squared is 2y dy dx plus y squared times derivative of negative x is negative 1. So low d high minus high d low all over low squared. So I think we're going to multiply this over to the other side and probably go and multiply it out. It's going to be 4 minus 4xy squared plus x squared y to the fourth equals 12 minus 6xy squared plus 6 or 12 plus 12x squared y dy dx plus 6xy squared. All right. Now we want to solve for dy dx, which I guess just shows up there, which is nice. It only shows up in one spot. This is a mess. All right, so we're going to subtract 12 from both sides. Add 6xy squared. 6xy squared. Subtract 6xy squared. I guess those could have just canceled out. So 12x squared y dy dx equals x squared y to the fourth minus 4xy squared minus 8. We'll divide both sides by 12x squared y. And I don't know if we can do anything about that. I don't feel like we can. So I don't know. That seems nice. If you cross multiply at the beginning, I guess that could make it a lot easier. The answers are going to look different too. But okay, 4, find the slope of a normal line to this curve, whatever it is. Well, you find the slope of the tangent line, which is the derivative, and then do the negative reciprocal. So you have a point. Find the slope of the normal line. So we got to take this derivative. It's going to be x squared times y, which is dy dx, plus y times derivative of x squared is 2x. And we have another one, x cubed times derivative of y squared is 2y dy dx, plus y squared times derivative of x cubed is 3x squared, equals derivative of 12 is 0. And we want to find the slope. Now, I'd plug in this x and y numbers right in right now. I think that's make it a lot easier. So you got 1 squared, 3, so you got dy dx plus 6 dy dx plus 27 equals 0. So we get 7 dy dx equals negative 33. So dy dx at the point 1 comma 3 equals negative 33/7, which is the slope of the tangent line. So the slope of the normal line is the negative reciprocal of that, so positive 7/33. Now you could have, so you could have gotten a nice equation for dy dx, up way up here. You could have got, dy dx in terms of x's and y's. The answer I got when I did it like that was negative 2xy minus 3x squared y squared over x squared plus 2x cubed y. Now, you can do that. You get show a bunch of work, and then plug in x equals 1, y equals 3 into this, and you'll get the same thing. So, all right, 25. This equation wants the second derivative. So let's find the first derivative, 2x plus 2y dy dx equals derivative 16 is 0. So we got to actually isolate dy dx before we get to the second derivative. So it's going to be 2y dy dx equals negative 2x. You can divide both sides by 2y. All right, so then the second derivative, we do quotient rule, low d high minus high d low all over low squared. Now we don't want dy dx in our final answer, so we're going to, the dy dx we got was negative x over y, so we're going to plug that in for this. So the second derivative equals negative y plus x times negative x over y squared. Now, I don't want fractions and fractions, so the quickest way to get rid of complex fractions is multiply everything by the least common denominator. Make sure it doesn't just reduce away on its own either. So it's going to be negative y squared minus x squared over y cubed for the second derivative. Now, this doesn't quite look like the answers that we have available to us. It seems like They either all have y's or all. I don't know. Maybe we got to get creative. Ooh, check this out. Look, original equation, if you multiply everything through by negative, check that out. Fancy. We could write this down as the second derivative is negative 16 over y cubed. So we had it, negative 16 over y cubed. Answer number 4. All right, that's it. Continue to get ready. There is an extra corrective, a corrective extra available to help you get ready. It's not required, but could use more practice.